Hi, everyone. Just wanted to take a moment to talk to you about conditional statements. Conditional statements are ultimately going to be when we're combining a couple different pieces of information into a cause and effect type relationship. And these are going to be super important to us in geometry because when we go into proofs, we are going to be explicitly proving conditional statements. And just as a broad overview, a conditional statement is an if-then statement that relates the hypothesis, that's the part following the if, to a conclusion, so the part following the then. You could represent it as P with that little arrow right there, Q, which you can read in a couple different ways. You could read it as P implies Q. We're saying the hypothesis implies the conclusion. You could also read it as if P then Q, where P represents again the hypothesis and Q the conclusion. So ultimately, we're going to be trying to illustrate some sort of relationship between two things. Now, in the case of identifying the hypothesis and conclusion, it's usually relatively straightforward. Again, it's just the part following the if in terms of the hypothesis. So on the first one, if I go to basketball practice after school, then I will be hungry when I get home. The I go to basketball practice after school is the hypothesis. You don't include the if. It's just the statement component. And then again, in the bottom one, if I am hungry when I get home, then I will make a sandwich. I am hungry when I get home would be the hypothesis. You just need to be careful. There's sometimes, you can write it in a kind of difficult manner where it's not always clear. For example, the bottom one you could write, I will make I will make a sandwich. I will make a sandwich if I'm hungry when I get home. It's not in the same PQ format. It's in QP, but ultimately it's still a conditional statement in the form of if P then Q. All right, let's take a moment and look down here. So we need to be careful when we're dealing with the truth values of conditionals. And the reason behind it is not so much the situation where the hypothesis is true, because these top two definitely make sense, right? If the hypothesis is true and the conclusion is true, the entire statement is going to be true, right? If P, then Q, both are true, then yeah, of course it's true. Makes sense. And if your hypothesis is true, we're saying if this is true, but our conclusion is false, well, that does not show a relationship, right? So we're saying if it's true, then it's false, the whole thing will be false. These bottom two ones are a little bit weird to kind of wrap your head around because we indicate that if the hypothesis is false, then the conditional is ultimately true, all right? It doesn't matter what is happening with the conclusion in the case that the hypothesis is false. The best way I can kind of explain why it is that way largely comes down to the fact of we're trying to illustrate, a relationship. And if the entire thing we're starting off on is not true, then it doesn't matter what I've written, right? It just doesn't matter because my initial statement just doesn't make any sense. So yeah, it's true, but the whole thing doesn't really mean anything. And that's kind of really the best way I can explain what's happening. It's where you're starting with something, but it doesn't even apply in the first place. So yeah, it doesn't matter what you're saying it concludes because it didn't matter in the first place. All right. So let's look at a couple situations. And most of what we're going to be dealing with is going to be these top two, right? We're going to be dealing with the premise being true. In fact, the hypothesis being true. We're going to predominantly be dealing with this top case as well in regards to proofs. And the other case down below would be kind of the ones where we find the counterexamples. So if a number is even, so we're taking that to be true, right? We're taking that a number is even. All right, we just have some even number. Then it is divisible by 2. Well, that's ultimately true, right? A number that is even is divisible by 2. So this whole conditional is true. However, on this one, we're assuming that, so we have, if a quadrilateral has two pairs of congruent angles, then it is a parallelogram. So in this particular case, we're looking at it and saying, we're assuming that we have a quadrilateral with two pairs of congruent angles, right? So we're saying that is a truthful thing. We have that. However, down here, we've illustrated that it's not a parallelogram. We've illustrated we can have one that is a isosceles trapezoid, where we do have two pairs of congruent angles. So therefore, this conclusion is false, right? We've illustrated a situation where my hypothesis is true, but then my conclusion was false, and therefore my entire conditional is false, right? So if we were to look at this particular example, what's the truth value of each conditional? Explain our reasoning. So let's start with the first one. Again, we're going to assume that we have a quadrilateral with a right angle, okay? Then it is a rectangle. Well, as you'll learn later on, if you have a quadrilateral with a right angle, it has four right angles. In general, well, that would be if it's a parallelogram. I'm sorry, I misspoke. We could have a right trapezoid. Right? We could have a right angle there. That is a trapezoid, but it is a right angle. So therefore, this part we are saying is true. But I just gave you an example where we have a right angle, and it's not a rectangle. If we were starting with a parallelogram has a right angle, then it's a rectangle. Yes, that would be true. However, quadrilateral, we just illustrated four sides. 1, 2, 3, 4. And it's not a rectangle. So this ultimately is going to be false. So the whole thing is false. If X is a midpoint of AB, then X lies on AB. Well, we're saying X is a midpoint of AB, of segment AB, right? Well, it's a segment. So by definition here, it kind of has to be on the segment, right? So yeah, that is ultimately going to be true. I can't think of a situation where we have a midpoint between one point and then a different point, but it's not on the segment itself. All right. So next, there's a couple other relationships that we can have in terms of conditional statements, and there are these things called the converse, the negation, the inverse, and the contrapositive. Okay, so the converse. So again, our conditional statement is if P then Q. Our converse is going to be if Q then P. So we're just flipping it, right? So if, let's go back to the one we had before. If a number is even, then it is divisible by 2. The converse, if a number is divisible by 2, then it is even. All right. The negation, again, we've already been over that, not P. So if a number is not even, or I guess you could say if a number is not even, you could say a dot, but we're going to explicitly use not even for ease of the not. The inverse, that's obtained from not P implies not Q. So if not P, then not Q. If a number is not even, then it is not divisible by 2. All right. The contrapositive, that one is not Q. If not Q, then not P. So if a number is not divisible by 2, then it is not even. So really, these are a little bit tricky just because you have to remember which one's which, right? So the converse is just you're taking P and Q and flipping them. The inverse and the contrapositive have the negations. So these are a little bit tricky just to remember what each of them are. So for example, if we're looking at this, to write it, okay, so here's our conditional. If you play the trumpet, then you play a brass instrument. That's a truthful statement, right? A trumpet, you're playing a trumpet, we're assuming that's true, and then it is a brass instrument. That is by definition what a trumpet is. So that's a truthful statement, right? Now, if we wrote the converse, we're just reversing the hypothesis and the conclusion. So if you play a brass instrument, then you play a trumpet. Well, not necessarily, right? You could play a trombone. You could play, a cornet, or you could really play any version of any sort of brass instrument. So right then and there, we're saying, okay, well, this one was true, but when we flip them, it's not true anymore. So ultimately, just because the conditional is true does not mean the converse will be true. All right. So again, if we were to do the converse, we have if a polygon is a quadrilateral, then it has four sides. So I'm going to write the converse. If a polygon has four sides, oops, then it is a quadrilateral. Now, um, a polygon with four sides is by definition what a quadrilateral is. So this one is going to be true on both accounts, right? It was true here. We're saying we have a quadrilateral. It has four sides. There's no such thing as a quadrilateral without four sides. If you have a polygon with four sides, it is just by definition a quadrilateral. So therefore, this one is still true. Okay. If two angles are complementary, then their measures add to 90 degrees. If their measures, okay, so if two angles add to 90 degrees, then they are complementary. All right, so that would be the converse there. In this case, we're saying if two angles are complementary, then their measures add to 90 degrees. Well, that's clearly true. And our particular definition, we did say that it did not necessarily matter if they were adjacent. There is some discussion that could happen between various textbooks and mathematicians on whether or not complementary angles have to be adjacent. But since we said they do not, if we have two angles that add up to 90, they are complementary. So that is still true. Okay. Now, we could do the converse, inverse, and contrapositive, and then we're saying what's the truth value of each. If it is a weekend day, then tomorrow is Monday. Well, that's actually not even a true statement, right? Because Saturday, right, this is actually false. Because if today is Saturday, then tomorrow is not actually Monday, right? But Saturday is a weekend day. So let's do the converse. If tomorrow, Monday, I'm just going to shorthand. Then today, weekend. That's true, right? If tomorrow is Monday, then today is a weekend, right? Well, tomorrow is Monday, it's Sunday, so today is a weekend day. So that is actually true. So we just had a situation where we started with it was false, but now when we do the converse, it's true. Now the inverse, not P implies not Q. So if not, so I'm sorry, if tomorrow is not a weekend day, well, let me just try that again. Sorry, that came across weird. I don't know what I was trying to write. So if tomorrow is not a weekend day, oh, shoot, not tomorrow. I'm sorry. If today, I was looking at my converse. That's the other thing you need to be careful of. When you write your inverse, you're basing it off the original, right? So if today is not weekend day, then tomorrow not Monday, right? Well, we already had kind of answered that. We're saying the only day where we're going to get tomorrow to be Monday would be if it's Sunday. So if it's not a weekend day, then tomorrow is by definition not going to be Monday. So that is still true. Okay. And then last thing, the contrapositive. And again, we have to be careful. If tomorrow is not Monday, then today is not weekend. All right, so let's think about this one. We have tomorrow is not Monday. Okay, so it could be Sunday, could be any day but Monday. So you have 6 options here. Are any of those going to be the weekend? Well, right. If today is if tomorrow is not Monday, so tomorrow's Sunday, but that would make today Saturday, which is in the weekend. So this is false. And just as a quick overview, we need to be careful, right? Because we just saw that number one, you can easily mix up where you're starting. Number two, they're not always all in the same situation. However, one thing to note is the conditional and the contrapositive are going to be the same. So if the conditional is true, the contrapositive is true. If the converse and the inverse, whatever they are, they're also going to be the same, right? Because if you look at their truth table, they're equivalent. And that just means that if we have a converse that's false, the inverse is also going to be false. If we have a conditional that is true, the contrapositive is also going to be true. Sometimes it's a little bit easier to think about it in terms of the contrapositive or in terms of the conditional or the converse and the inverse than some of the other ones. The only difficulty thing on this one is that knowing something about the inverse and the converse doesn't tell you necessarily anything about the conditional itself, right? So if my goal is to figure out what's going on with the conditional, you can look at the contrapositive and you could look at the converse, but the converse isn't necessarily going to give you any information because it doesn't mean that one is inherently true, right? So you just need to be careful when you're looking at those. All right. Please let me know if you have any questions. Have a great day.